Hi, welcome to part 4 of the video series about laws of motion. In the previous video, we have defined equilibrium and then solved 3 examples to understand the equilibrium better. In this video, we are going to state the second law of motion and solve 4 examples to see it in practice. Let's imagine 3 objects. First two of mass m and the last one of mass 2m. If we apply a force of magnitude F on the first object, it will accelerate at an acceleration of a. Then we apply a force of magnitude 2F on the second object. We notice that it accelerates at an acceleration of 2 times a. As we can see, if we double the force, acceleration of the object has also doubled. According to the result of these 2 observations, we can say that the acceleration of an object is directly proportional to the net force applied on this object. Now, if we apply a force of magnitude of 2F on the last object, this object will accelerate with an acceleration of magnitude of a. As we noticed, if we keep the force constant, acceleration of the object is inversely proportional to the mass of this object. If we increase the mass 2 times, acceleration decreases 2 times. Second law of motion is the combination of these 2 observations. When a resultant or net force acts on an object, the object will accelerate in the direction of this force, and the acceleration is directly proportional to the net force and inversely proportional to the mass of this object. We can formulate it as acceleration is equal to the ratio of the net force applied on an object to the mass of the object. We can also write this equation as net force is equal to the product of the mass of an object and its acceleration. Now, let's solve some simple examples to learn how to use this formula. In the first example, we have to calculate the acceleration of a 5 kg object, which is moving under the influence of a force of magnitude of 40 newtons. Even though this question is very simple and we don't have to draw it, it is a good habit to start solving these type of questions by drawing free body diagrams. As a first step, we draw a dot to represent the object. Then we draw the applied force F. The second force applied on this object is the force of gravity. And the last force is the normal force, as the object is in contact with the surface. For this question, force of gravity and normal force cancel each other, as they are equal in magnitude and opposite in direction. Net force for this question is equal to the applied force only. Another nice habit in the exam is to start our solution with a formula, as for most of the questions, we will get a mark for writing down the correct formula. According to the second law of motion, the net force is equal to the mass times acceleration. After substitution, we get 40 is equal to 5 times acceleration. Acceleration is equal to 8 meters per second square to the right. Direction in this question is very important as the question asks for the acceleration. As we know, acceleration is a vector quantity, and vector quantities consist of both magnitude and direction. If we skip one of them, most probably we will miss at least 1 mark in the exam. The second example is just a slightly difficult version of example 1. Now, instead of a single force, there are 2 forces applied on an object to the right. Again, we start by drawing the free body diagram. The forces applied on this object are F1 to the right, F2 to the right as well. Force of gravity as usual downwards. And finally, normal force in upward direction. Net force is equal to the product of mass and acceleration. We neglect force of gravity and normal force as they will cancel each other. 40 plus 60 is equal to 5 times acceleration, as mass of the object is 5 kgs. Acceleration is equal to 100 meters per second square to the right. The only difference of the third example from the previous one is that the second force is directed to the left instead of right. We draw free body diagram for this object as well. F1 is to the right, F2 is to the left, force of gravity is downwards, and the normal force is upwards. For this question, let's choose right as positive direction. In this case, F1 will have a positive value and F2 will have a negative value. Fnet is equal to mass times acceleration is our formula. Then we can rewrite this formula as F1 minus F2 is equal to mass times acceleration. 40 minus 60 is equal to 5 times acceleration. And acceleration is going to be negative 4 meters per second square. For a vector quantity, if we get a negative value, we rewrite the answer by mentioning both magnitude and direction. In this case, acceleration is equal to 4 meters per second square to the left. The last example is a bit complicated one. Two forces are acting on a 5 kg object at a right angle to each other. The task is same as in the previous examples, to calculate the acceleration of the object. As usual, we start our solution by drawing a free body diagram. There are two forces applied on this object, F1 applied to the right and F2 applied upwards. Normally, there should be a force of gravity applied on this object as well, but in the question, it is asked to ignore all other forces. So we can assume that F2 is the net force in the vertical direction. As F1 and F2 are perpendicular to each other, we can use tail-to-tail method to calculate the resultant vector. You can click on the link above if you want to learn more about addition of two vectors which are perpendicular to each other. As we know, in tail-to-tail method, from the head of each vector, we draw a parallel to the other one. Resultant force is the diagonal force starting at the connection of tails. To calculate the magnitude of the resultant vector, we will use Pythagoras theorem. Square of the net force is equal to the sum of squares of F1 and F2. So it is equal to 50 square plus 100 square. As a result, the magnitude of the net force is equal to 130 newtons. Once we know the value of the net force, we can use the second law of motion to calculate the acceleration of the object. According to the second law of motion, the net force is equal to the mass times acceleration. Net force is 130 newtons and mass is 5 kgs. Acceleration of the object is 26 meters per second square. Even though it took a lot to calculate the magnitude of the acceleration, we are not done yet. We have to calculate the direction of the acceleration as well, as acceleration is a vector quantity. And vector quantities have both magnitude and direction. Unfortunately, in most of the exams, we forget about this part and move to the next question once we have the magnitude calculated. Let's be vigilant and be sure that we have completed all the steps. As we learned in the video about the components of a vector, to calculate the direction of a resultant vector, first we have to specify an angle on the diagram. Then we can use inverse of a tangent to calculate the value of this angle. Theta is equal to the inverse tangent of F2 over F1. In other words, opposite side to theta over adjacent side. F1 is 120 and F2 is 50 newtons. Theta is going to be equal to 67.38 degrees. So final answer for this question is that the magnitude of the acceleration is 26 meters per second square and its direction is 67.38 degrees. As a summary, in this video we have defined the second law of motion and then solved some examples to solidify the newly gained knowledge. In the next part of this video series, we will state the third law of motion and solve some multiple choice questions related to the topic. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.